This is Dr. Holt. In this video, this is a web-assigned problem. I have a particle. It's going to be initially located at the origin, has an acceleration of 1.00 meters per second squared j hat, an initial velocity of 9 meters per second I hat. We need to find the vector position of the particle at any time. We want to find the velocity of the particle at any time. We want to find the coordinates of the particle here at t equals 5 seconds, and we want to find the speed of the particle at t equals 5 seconds. What I recommend with a problem like that is to identify what you know. Okay, we do know here that the acceleration is going to equal to, and we can put 0 in the I hat plus 1 j hat. Okay, and again, those units are going to be meters per second squared. We know our velocity vector 2. Our velocity vector here is going to be 9 I hat plus 0 j hat meters per second. And feel free to go ahead and put the units after right in here in all cases. Sometimes I like to just put them out on the side just because it simplifies it. Okay, we're going to go ahead and write our kinematic equations right now. Let me identify one more thing though. This is key too. It's at the origin. So if it's at the origin, we know our initial position in the x and the y is going to equal to 0. So our kinematic equation is going to be x is equal to x I plus our velocity initial times t plus 1/2 times our acceleration t squared. Again, let me grab my pen. We know in all cases, whether we're going in the I hat or the j hat, that this is going to be 0. 0 again because we're starting at the origin. Alright, let's go ahead and write our velocity equation. We know that velocity at a point in time is going to equal to our initial velocity plus our acceleration times t. Actually, I think that's only probably the two kinematic equations we're going to need to do this problem. Okay, part A is going to ask us, grab a pen here, is asking us to find the vector position of the particle at any time where t is measured in seconds. So I'm going to be working just with this equation here. So again, we know our initial position is 0. So it says to take the velocity and multiply it by t. So we'll start down here and we come to our velocities. Well, this is our velocity equation. So I can take 9 I hat plus 0 j hat and multiply that times t. And now I have plus 1/2 times my acceleration, and I can put 0 I hat plus 1 j hat times t squared. Okay, we will simplify this. This gives me x is equal to 9 t I hat plus 1/2. I'll use 0.5. You can use, it doesn't matter. I'll put 0.5 times 1 t squared j hat. And you can go ahead and write it to match what the answer is. I'm sure that it would accept this, but then x is going to equal to 9 t I hat plus 0.5 t squared j hat, and your units are going to be in meters. Okay, and again, that's how you get part A. Exactly, and it matches perfectly. All right, the second question, get another pen, is asking you to find the velocity of the particle at t equals 0. I'm going to go ahead and erase this so I have some room to get everything in here. And if you need to go back and look at it, just back up the video. Okay, to find the velocity, we're going to be working with this equation here. So the velocity equation says to take the initial velocity, and we're going to do this in the I hat and j hat. We'll come up and we're looking at right here at this equation. So I got 9 I hat plus 0 j hat. Okay, and now we're going to add it to our acceleration plus our acceleration, and that's going to be right here. And we do 0 I hat plus 1 j hat, and it says to multiply it by t. Okay, let's simplify that. When we simplify that, we will get our velocity is equal to 9 I hat plus 1 times t j hat. Circle that in red. And again, you notice this is going to match exactly what I have here. Alright, let's erase again. Give myself a little bit more space. Okay, part C says find the coordinates of the particle at t equals 5. Well, we know earlier that we wrote our position equation. I'll just go back to this one, was equal to 9 t I hat plus 0.5 t squared j hat. And this one says find the coordinates of the particle at 5 seconds. Well, in the I hat direction, I would just put the 9, I'd multiply it by 5, and I hat here, and that's going to give me 45 I hat. And again, we're talking about in the units of meters. Okay, to find the y position, I'll just change this x to y, meaning we're going in the vertical direction. And we use the 0.5, and we plug in our time of 5. We square that, 25, 5 squared is 25 times 0.5 is going to give me 12.5 meters. Okay, and you can leave the I hat and j hats off because you've identified it already as x and y. Alright, to find the speed at 5 seconds, let me erase this real quick. Right, to find the speed, we'll be using this velocity equation here. We will find it in the both coordinates. So let's write what the vector part would be. So let's do the velocity first. The velocity, again, we know in this one, I'm going to write it all out again. We said, actually, let's just go back. We already have the velocity one. Let's just do 9 I hat plus 1 times t j hat, and we're going to do it 5 seconds. So when my velocity equation equal to 9 I hat plus 1 times 5 j hat. Again, these are vectors. You cannot add these together. So we know our velocity in the I hat direction. I'll write it all out. Just simplify it as 5 j hat. Now, to find the speed, you need to write, and you're just going to go right to Pythagorean Theorem. Often you're going to see it written like this, meaning speed, and we go back and we're looking for the length of this vector here. and we're going to do 9 squared plus 5 squared. 9 squared is 81. 81 plus 25 is 106. To take the square root of 106, and you'll get approximately 10.3 meters per second. And remember, this is a scalar quantity. This is not a vector quantity. Alright, and that's how you get part D. Alright, hope this video was useful. This is how to use really the kinematic equations when you're dealing with vectors. Alright, best of luck.